The silence of interstellar space is vast, cold, and near absolute. For eons, a dark object, barely a few kilometers across, tumbled through that void, ejected from its home star system countless millennia ago. Now, it has entered ours. It is the third confirmed interstellar visitor, 3I Atlas. Its arrival redefines our understanding of the galactic neighborhood. The first visitor, 1Y Oumuamua, was an anomaly. Fast, rocky, and strangely accelerated. The second 2I Borisov was more familiar, a clear comet rich in carbon monoxide, but still a comet from another sun. I Atlas is different again. Early spectroscopic data suggests a composition that defies easy classification. Plausible mechanisms. It possesses a CO2-dominated coma, similar to Borisov, indicating it formed far from its host star. However, early detections of OH taus and H2 tau suggest that water ice is also sublimating unusually early, or that its surface is a complex mosaic. But the true challenge of 3I Atlas is not just its chemistry, it is its calendar. Its trajectory through the inner solar system in 2025 is an observational nightmare and a once-in-a-generation opportunity. Verified facts and dates. The sequence of critical events is unforgiving. On October 3, 2025, the comet will pass relatively close to Mars. This flyby is our first and last clear chance for Martian orbital assets, like ESA's Trace Gas Orbiter and NASA's Mars Reconnaissance Orbiter, to study it before it dives into the solar glare. Immediately after its Mars encounter, 3I Atlas accelerates toward its perihelion, its closest approach to the Sun, which will occur around October the 29th to 31st. This is where the comet will unleash the bulk of its volatile material. It is the moment its nucleus might fragment, where its dust tail will reach maximum extent, and where jets from its surface will reveal the internal structure of this alien visitor, and we will be blind. The central problem is the superior solar conjunction. Verified facts and dates. On October the 21st, 2025, just a week before perihelion, 3I Atlas will align almost perfectly behind the Sun from Earth's perspective. For ground-based telescopes, the comet will be lost in the twilight. For space-based observatories like Hubble and JWST, pointing that close to the Sun is a catastrophic risk. The direct sunlight could fry their optical instruments. We are facing a data blackout. The comet will be at its most active, most revealing, and most vulnerable precisely when our most powerful eyes are forced to look away. This is the scientific challenge of 2025. How to observe an interstellar messenger as it flies directly through the fire. Before 3I Atlas becomes a solar ghost, we have one critical window. Verified facts and dates. The October 3rd, 2025 Mars flyby is our forward observation post. It is not a close encounter in planetary terms, but it is close enough for our robotic fleet at Mars to retask their instruments. ESA's Trace Gas Orbiter, TGO, designed to sniff for methane in the Martian atmosphere, will aim its spectrometers at the visitor. NASA's MRO and MAVEN, veterans of the Mars orbit, will coordinate observations to capture the comet's light. There are even experimental protocols for the Perseverance rover to attempt a detection from the surface. This effort is not for a simple photograph. It is to establish the baseline. We need to know what 3I Atlas is before the Sun cooks it. Plausible mechanisms. The initial spectroscopic analysis has already revealed a fascinating chemistry. The coma, the temporary atmosphere around the nucleus, is heavily dominated by CO2, carbon dioxide. This suggests the comet formed in an extremely cold region of its home star system. So cold that CO2 froze out as abundantly as water does here. As it nears the Sun, this CO2 ice sublimates violently, driving the comet's early activity. Alongside the COU2, we see expected signatures like CN, cyanogen, and, crucially, CH2, diatomic carbon. CTSUD2 is responsible for the famous green glow, the swan bands, seen in many solar system comets, a fluorescence excited by sunlight. But there is an anomaly that teams are scrambling to confirm. Verified facts and dates. Preliminary reports have suggested the presence of spectral lines for nickel, Ni. This, by itself, is not unheard of. Gaseous nickel has been seen in solar system comets. The strangeness is the apparent absence of iron Fe alongside it. In meteorites and most rocky bodies, nickel and iron are intimately linked. To see one without the other defies our models of planetary formation chemistry. Plausible mechanisms. Is this a measurement error, or is the solo nickel telling us something fundamental about the material this comet is made from? Perhaps a nickel compound that vaporizes at a different temperature than any iron compound present. Beyond chemistry, the Mars flyby is vital for physics. We must accurately measure two competing forces. First, radiation pressure, sunlight physically pushing the dust grains in the tail. Second, non-gravitational acceleration, the rocket effect of CO2 gas jetting from the nucleus as the sun heats it. If we can quantify these forces on October 3rd, we can better predict how the comet will behave when it faces the peak heat of perihelion. The Mars data is the initial setting. It is the last clean photograph of our subject before it enters the solar system's most intense interrogation room, the solar corona. The countdown to the conjunction has begun. How do you see something that is invisible, drowned in the light of its own star? This is the central problem of the October 2025 conjunction. Verified facts and dates. On October 21st, 2025, Dria's Atlas will pass behind the Sun. Just days later, around October 29th, it reaches perihelion, its closest, hottest, and most violent encounter with the Sun. It will be at its most active, and we will be completely blind. Observatories like the James Webb Space Telescope are useless here. Its giant sensitive sun shield, optimized for cold infrared viewing, restricts it from ever looking near the sun. This leaves only one instrument, the Hubble Space Telescope. Verified facts and dates. But Hubble has its own limits. It operates under a strict 50-degree solar avoidance angle. Pointing any closer risks the focused sunlight entering the telescope tube, boiling its lubricants, and permanently frying its sensitive detectors. 3i Atlas will be deep inside this 50-degree forbidden zone. This situation demands one of the riskiest, most precise observation protocols ever attempted with the 30-year-old telescope. This is the Hubble Gambit. Plausible mechanisms. The protocol does not involve pointing directly at the sun. Instead, it's a maneuver of precise timing, using the entire Earth as a shield. As Hubble orbits, it spends roughly 30 minutes in Earth's shadow, our planet's eclipse. The plan is to execute a target of opportunity observation during this brief window. Just as the Earth occults the sun, blocking the catastrophic direct light, Hubble will rapidly slew into the forbidden zone and lock onto the position where 3i Atlas is known to be. It will have only minutes. The goal is not a beautiful photograph. The goal is data. We need to measure its brightness, its morphology. Is the nucleus fragmenting? Are the CO2 jets intensifying? Testable predictions. If the comet is already disintegrating, Hubble will detect a rapid, anomalous brightening or an elongation of the coma before it reaches perihelion. This data is the only bridge between the Mars flyby in early October and the comet's reappearance in December. But the Gambit could fail. The stabilization system, the fine guidance sensors, must find stable guide stars. In the sun's overwhelming glare, even from behind the Earth, the sky will be noisy and washed out. If Hubble cannot lock on, the window closes, the telescope must slew back to safety, and the data is lost forever. This is the definition of high-risk, high-reward science. We are attempting to gather the only data that exists from the comet's trial by fire. The data retrieved by Hubble during the conjunction is noisy, contaminated by solar glare, and incomplete. But within that noise, the morphology of 3I Atlas reveals two distinct and potentially competing structures. The first, and most obvious, is the anti-tail. Verified facts and dates. In the processed images, we see a sharp, narrow spike of light pointing not away from the sun, but directly towards it. This is not a new or mysterious phenomenon. This is a classic anti-tail. It is an illusion of geometry, plausible mechanisms. A comet's main tail is gas and fine dust, pushed away from the sun by solar wind and radiation pressure. But a comet also releases heavier, pebble-sized grains. This material is too massive to be affected by the solar wind. It simply gets left behind, spreading out along the comet's own orbital path like a thin, flat sheet of debris. For most of an orbit, this sheet is invisible, but when Earth's orbit intersects that orbital plane, as it does for 3I Atlas during the conjunction, our line of sight sees that sheet edge on. This perspective trick compresses the entire fan of debris into a single, bright spike that appears to defy physics and point at the sun. The anti-tail is made of old, cold dust, but the Hubble data, once the anti-tail's glare is filtered, hints at something else. A second, weaker structure, plausible mechanisms. Buried in the noise is a faint, possibly curved jet of material, also oriented sunward, but originating directly from the nucleus. This is not the anti-tail. This appears to be an active, low-velocity jet of gas, likely CO2, being vented from the day side of the nucleus. This subsolar point, the spot facing the sun's full fury, is the hottest part of the comet. Any ice there would sublimate violently, creating a jet that momentarily pushes against the solar wind before being bent back. This is the key to the non-gravitational acceleration debate. If 3I Atlas has active jets on its sunward side, they act like small rockets, braking the comet and subtly altering its path. To predict its orbit, we must know if this jet is real. Testable predictions. The two structures will give themselves away over time. As 3I Atlas reappears from the sun's glare in late 2025, our viewing angle will change. The anti-tail, being a geometric illusion, will broaden, fan out, and fade. The sunward jet, however, if it is a real feature of the nucleus, should remain visible, its shape perhaps changing as the comet itself rotates. The brief, high-risk Hubble observation is the only data that captured both simultaneously. The images retrieved from Hubble's brief 20-minute dash through Earth's shadow are not photographs. They are statistical nightmares. Getting the observation during the conjunction was the gamble. Trusting the resulting data is the true challenge. This data is scientifically dangerous because a conclusion drawn from dirty data profoundly contaminated by the sun, is worse than no data at all. It sends future missions chasing ghosts. By late 2025, the solar system will provide the ground truth. The core task is separating the signal, the faint interstellar comet, from the overwhelming systematic noise, the solar glare. Plausible mechanisms. The primary systematic error is stray light. The sun, even while fully eclipsed by the Earth's solid disk, creates a brilliant ethereal corona. This light does not enter Hubble's aperture directly, but it floods the surrounding environment. Photons skim the edge of the telescope tube, scatter off the reflective outer shell, and find paths around the primary mirror baffles. They strike the internal spider veins that hold the secondary mirror. Each reflection scatters light across the detector, creating artificial gradients, false spikes, and a background fog that can easily hide a faint jet or, worse, create the illusion of one. A second related error is detector saturation and charge bleeding. The glare is so bright in some areas of the detector that it completely overloads the individual pixels. A saturated pixel cannot hold any more charge. It bleeds vertically into adjacent pixels up and down the detector column. Plausible mechanisms. This process can make a sharp defined feature, like the anti-tail, appear artificially smeared or elongated. It could make a faint, linear artifact look exactly like the weak sunward jet we are searching for. The jet, the key to the comet's non-gravitational acceleration, might just be an echo of the glare, an artifact of the sensor itself. To excavate the truth, scientists must deploy a painstaking multi-stage methodology. Verified facts and dates. The observation protocol was designed to measure these errors. It's a key part of the director's discretionary time awarded to the team. For every image taken of 3I Atlas, Hubble also took an image of an empty patch of sky nearby, using the exact same exposure, time, and telescope orientation relative to the sun. This offset frame captures the background glare, the stray light pattern, and the detector noise without the comet. This offset frame is the template of the error. The analysis team can then use complex subtraction algorithms to remove this glare map from the comet map. Image plus its error. Error helix image. But even this is not enough. They must also use sophisticated computer models of Hubble's optics, the point spread function, PSF, to simulate what a perfect point of light should look like under these specific, terrible lighting conditions. Verified facts and dates. This process is why the scientific community must prioritize rigor over speed. When the Hubble data is processed, we must distinguish institutional delays, the weeks required for this meticulous error analysis, peer review, and independent cross-checks, from sensationalist claims of coordinated silence. Any team that rushes to conclusions, perhaps about the Nephi anomaly from the Mars data or the sunward jet from the Hubble data, risks confusing an instrument artifact with an interstellar discovery. Good science demands hygiene. This is the hygiene. The entire endeavor rests on this analysis. Testable predictions. If the error analysis is robust and the weak sunward jet is confirmed to be real, then the non-gravitational acceleration it provides must be factored into the comet's orbit. This jet-assisted model predicts a specific arrival time and position for the comet when it re-emerges in December. A competing model, one that assumes the jet is an artifact and only gravity is at play, predicts a slightly different position. The analysis of the Hubble conjunction data was not a purely academic exercise, it was a critical, time-sensitive calculation. Testable predictions. The solar system itself provided the laboratory. The weak sunward jet, if real, was actively applying a minute, non-gravitational braking force to the comet every second it was near the sun. When multiplied over weeks, this thrust measurably altered the orbital path. It will fall silent as it returns to the interstellar dark, carrying the scars of its violent encounter with our sun and leaving us with a captured piece of its chemical soul. The model incorporating this force predicted 3I Atlas would reappear in December 2025 at a specific adjusted location in the sky. The competing, simpler, gravity-only model predicted a slightly different position.
The trajectory is locked.
The difference was small, but detectable. This was the test. Verified facts and dates. As 3I Atlas swung away from the sun, its orbital elements now forever altered by the perihelion passage, observatories on Earth began the recovery campaign. In December 2025, the comet reappeared. It was not where the gravity-only model predicted. The recovery images from multiple ground-based observatories confirmed the jet-assisted model. The artifact hunting, the systematic error analysis, the subtraction of the glare map, it had worked. The faint sunward pointing jet observed by Hubble during the conjunction was real. This confirmation is more than just a win for the Hubble team. It provides a physical calibration for the entire comet. We now have a reliable constraint on its mass-to-thrust ratio. We know the CO2 jets were powerful enough to change its path. With its trajectory confirmed, the focus shifts to its final post-perihelion analysis. Verified facts and dates. The next key date is March 16, 2026. This date has nothing to do with the Sun. It's about Jupiter. As the comet moves into the cold, dark outer solar system, it aligns in a favorable geometric configuration with Earth and the gas giant. This alignment is crucial for observatories like the James Webb Space Telescope. Plausible mechanisms. Now far from the Sun, the comet is cold again, and the overwhelming glare that blinded Hubble is gone. JWST, which could not look at the Sun, is the perfect instrument to look away from it. It can safely conduct high-resolution spectroscopy, breaking the comet's faint light into its chemical fingerprints. This is the moment of chemical truth. The Mars flyby gave us tantalizing hints of the strange Nin-Fe nickel-to-iron ratio. The JWST observation, cross-checked with the ground-based data from December, will confirm it. Testable predictions. If the nickel without iron anomaly holds, 3I Atlas is not just a comet. It is a fragment of a planetary building block from another star, formed in an environment with a chemical balance profoundly different from our own. It forces us to ask, what kind of stellar forge creates metallic compounds that vaporize this way? What does this imply about the diversity of planets in the galaxy? The legacy of 1I Oumuamua, 2I Borisov, and 3I Atlas is this: the galaxy is exchanging material. Verified facts and dates. These objects are not once-in-a-lifetime events. They are the first raindrops of a storm. We are realizing that our solar system is constantly being crossed by messengers from other worlds. 3I Atlas in particular has rewritten the rules of observation. It forced a high-risk gamble with our most valuable assets. It proved that a calculated risk, even one that pushes an instrument to its absolute operational limits, is necessary when the target is unique. Furthermore, it provided a masterclass in data hygiene. It emphasized that scientific silence is often just the necessary, quiet period of meticulous, responsible analysis. The time required to check the data, hunt the artifacts, and replicate the results before making an extraordinary claim. Verified facts and dates. In the coming years, 3I Atlas will pass Jupiter's orbit, then Saturn's. It will grow cold and dark, its CO2 jets freezing solid.